Okay, I'll try not to fall off the stage. Thanks for coming to the talk. Before I get started, I just want to see, I assume there are a lot of Spark users in the group. How many people are currently using Solr right now? All right, good, about probably 40, 45%. And then has anybody actually used the Spark Solr integration project yet that I'm talking about? All right, good. This will be a good talk for everyone. So basically, I'm going to talk about an open source project that I created, probably started about 9 months ago. Is Taka in the crowd? Does see Taka? Yep, there he is. So he came to me about 9 months ago here in San Francisco and was like, you know, what's the story with Solr and Spark? And I was kind of like, well, we don't really have one. So that was born out of this idea, and you know, Tuck and I started sort of integrating, communicating, interacting. And this is kind of where we are today, and there are some actually exciting features that we're actually working on. So I'll go ahead and get started. I'm a committer for the Solr project. So mainly my day job is actually working on Solr. I focus a lot on the distributed features. Probably heard of it, called Solr Cloud. I also did the bin Solr scripts, including the Windows one, which was pretty painful, but it's there now. I also was the co-author on Solr in Action, which is a book about Solr. And then when I'm not working on Solr, I work on a lot of kind of integration type projects like this one. I did the Solr on Yarn work, as well as some Storm and Solr integration. So I kind of like to also work around the ecosystem around Solr. So for those of you that didn't raise your hand about using Solr, it's an open source search engine. It's one of the more popular ones, and there's actually quite a vibrant and very active community. We just released Solr 5.2. It's very exciting. Solr 5 was kind of our big milestone of shedding off some of our old legacy. Solr's been around for quite some time, and really kind of putting a new feel on Solr. And then 5.2, we've just been hardening. For example, we added a sort of a new security layer, so you can maybe secure your Solr along with the rest of your Hadoop distribution using something like Ranger, so you can plug that into Solr. One of the pieces I worked on actually about a year ago, I did some benchmarking work with Solr, and we kind of found that replication, it was just a little slower than it should be. And so recently in 5.2, I implemented some fixes that we actually got over double increase in indexing performance. So if you're interested in high throughput type indexing, building Solr indexes, definitely check out 5.2. And there's other exciting features, sort of like using hyperlog if you want to estimate cardinality on a field. I don't know what that is, so I'll just leave it at that. And then also, we're getting smarter about laying out Solr in a bigger cluster, such as doing rack awareness and those kind of things. And then lastly, I mentioned the Yarn on Solr. So if you're sort of running Yarn and you're using Slider on Yarn, I'm sorry, not Slider, Spark on Yarn, and you actually want to add Solr, you can now do that. And the next version of Slider, which is an Apache source project that allows you to sort of deploy applications like Solr on a Yarn cluster. Solr is going to be distributed with like the next release of Solr. So that was awesome. They picked that up for us. Open source project, I won't talk too much. This is our value add product on top of Solr. It's called Fusion. And it pretty much has everything that like Solr doesn't have that you still need for a search. And the reason I think it's worth mentioning here is that actually in Fusion, we use Spark under the covers to implement a lot of the heavy computations that you need in a search engine. And the most obvious example there is we analyze query logs to see how users are actually using your search engine. For example, in an e-commerce setting, you know, people are searching for products. What are they clicking on after they put a particular query in? There's a natural feedback loop there that actually has to be computed, and we use Spark under the covers to figure out, you know, what is that feedback loop between actual user behavior in the search engine and how the search engine's actually working, you know, using basic ranking techniques. And we use Spark to actually come back and influence some of the document ranking and boosting inside of Solr and Fusion. So if you're interested in like recommendations and those type of things, definitely take a look at Fusion. Let's go ahead and get started. I want to talk about probably the most obvious example of Spark and Solr integration, and that is you have data, you want to process it, typical ETL type pipeline stuff, through Spark. Maybe you're running it through a machine learning algorithm. If it's tweets, you want to maybe try to gauge sentiment. If you figured that out, let me know, because that one's still a hard problem to solve. But the example here is basically, as tweets flow in, you want to do some sort of enrichment and transformation on them, and then index them into Solr. And so the project, the open source project that we've developed, makes that very easy to do. Okay, so here on the left, you have tweets flowing in. Spark obviously ships with the ability to actually read tweets very easily. Then you do some enrichments. That's the purple there in the slide. And then there's this mapping step. You have to map it to something that Solr can ingest. And the project itself tries to make that as easy as possible. And one of the things is like it can use Java reflection, which isn't the fastest of techniques, but it's really easy, especially when you're just getting started. If you want to basically throw an object, it'll try to figure it out and then send it on into Solr. It does some other things like just processing JSON and all those kind of things. Or you could use Fusion, which actually has its own built-in, again, based on Spark, mapping and transformation engine. So this code slide here, I apologize for those in the back. The point is, it's basically a one line of code when you're ready to index docs into Solr. You basically just say index D stream of docs. It doesn't have to be a D stream. It can also just be any RDD. But for me, the probably most common use case is you have a streaming workflow and you want to send them in to Solr. Let's see a little bit what goes on behind the scenes here. So behind the scenes, Solr is this distributed search engine that breaks up with what we call a collection. It's a distributed index into multiple shards, typical data partitioning scheme. The index is too big to fit on one machine, so we basically shard it out. And each shard in Solr has what we call a leader, and that leader is responsible for actually taking in a document, applying some basic things, indexing it, and then actually driving the replication out to X number of replicas. I had mentioned we improved a lot of the indexing performance around that. So this is kind of the area where I work to fix that. On the Spark side, and that's kind of depicted here in the blue box, Spark is essentially, and this could be a streaming job, is sending small batches of documents to what's called Cloud Solr Server. In 5, it's actually been renamed now to a Cloud Solr Client. And that thing is actually a pretty smart client in that it goes out to Zookeeper and it gets metadata about your collection, and it knows where all of these shard leaders live, essentially on the network. And what it does is it takes a small batch of documents and it breaks that up into even sub-batches and then routes them directly into each shard leader, right? And it does all this transparently behind the scenes. And since it's based on Zookeeper, if, for example, one of your leaders go down, we automatically fail over to another replica and keep processing, and the Cloud Solr client there will actually pick that up and start routing to the new leader. So all this is happening behind the scenes, and in terms of performance, this actually does pretty well because we are doing this sort of direct routing to the location where the documents need to end up on the cluster. One of the things that doesn't quite work with like Spark is the idea that we have to batch on the client side to get good performance because, again, as documents are flowing through your Spark streaming job, for example, you don't want to send 10,000 requests to every shard leader, right? That's just too much network overhead. So one of the things we do behind the scenes is that we build up these small like micro batches, and that kind of keeps down the amount of network overhead in indexing docs. The problem is, though, as you can imagine, how do you know how big to make those batches? How long do you hold on those docs before you flush them out to Solr? And so one of the things I'm working on, And this is actually coming soon. This is in the project. If you check it out from GitHub, this class will actually be in there. And the idea is to have a shard partitioner. So as, for example, in Spark Streaming basically takes a stream of docs and uses some time window to create your RDD, right, called microbatching. And it uses that, and then it partitions it. So if we use a shard partitioner, we're going to basically route to these things that can basically talk to the Solr leaders. And that's all well and good. But again, as I mentioned, you have to kind of batch things up in memory, and that's not so good. Solr has built into it what's called concurrent update Solr client, and this thing is actually a streaming technology and performs a lot better because it's not holding up and it's not building up batches. So as documents flow through, it's essentially keeping an open connection to Solr and sending them through. The reason why I say this is coming soon is because there's a bug in Solr that we're actually trying to fix. Bug feature. If something goes wrong and we hit a bad doc, then the actual error handling around all of this and the streaming is not as easy if you send a batch, right? Error handling on a streaming approach is a lot harder. And so there's some work to be done in how Solr actually returns back to the client like, hey, you sent me a bad doc. It's your problem to figure out why it's bad. I'm going to keep processing good docs. So we're working that out. Essentially, probably in 5.3 or thereabouts, Solr will have that problem fixed, and this will do better. But right now, in my performance analysis of Spark and things like that, on a 10-node cluster in EC2, I was getting right around 80,000 docs per second, which is pretty good, and that's with replication turned on. So varies based on your, your data and that kind of thing, but the throughput's actually quite good. Okay, so now we've talked about getting data into Solr. Let's also look at the other problem, which is you have data in Solr, and a lot of people that actually run Solr or any kind of search engine, that's typically pretty mission critical data. And so the idea here is that you actually want to bring some of that data into Spark and do some additional computation on it, join it with something in Hive or some database. That's fine. So the project here has this idea of a Solr RDD. And the idea there is that you basically can execute any query in Solr, including the just table scan query, give me all data in a collection, and it'll bring back a Java RDD. Right now, the project, since Solr has ships with a Java-based client, this project is more Java, but you could use it from Scala pretty seamlessly. Taka said he was going to take on the Python stuff for me, so. The key here with the reading is it's not so much hard. It's not that hard. It's the fact that how do you make it very performant, right? The idea behind Spark is that we have this big distributed cluster. How do we make it so that we can read data from Solr, join it with other things in a very efficient and fast manner? So a couple of the tricks we do behind the scenes, here's a little example of how it works, is that when you send a query in to this Solr RDD, again, it goes into Zookeeper and knows your index. It knows how it's sharded. So it can basically say, okay, the easiest way to break this up and parallelize it is for me to hit every shard in parallel, right? So that's the first kind of partitioning that it does. And to do that, it actually has to go out to Zookeeper, find out where all the shards live, and then set up this distributed equals false. So it's the same query, except for now it's only sent to each shard in parallel. And that's pretty good. The other thing it has to do is, and this is more probably information than you need, but querying into a search engine like Solr, you don't want to request all the rows that are in that because it'll just bog down. So you want to actually almost do like a paging type process. And very similar to when you page through a database. The problem is that's actually really inefficient unless you use what we built into Solr, which are called depaging cursors, okay? And so the Solr RDD takes care of all that, and depaging cursors is actually very, very efficient for reading data out of Solr. The next thing it does is if you have this big Spark cluster, and you have hundreds of millions of rows to read out of Solr, sometimes the partitioning scheme, maybe you only have 10 shards, isn't enough, because then you're only going to get 10 tasks in Spark running concurrently, right? Because one for each shard. So what we've also done is we give you the ability to pass us an additional field, which is like a numeric field that we can basically do range queries on, which will give us a level of parallelism. So the idea there is I'll take a field, figure out its min and max, and split it up into, say, 100 different buckets. And now I can query into each shard 100 different tasks in parallel instead of just one. And so the framework allows that. And this allowed me to read on, I think it was a pretty modest sized Spark cluster, maybe 5 nodes in EC2, and then a 10-node cluster in Amazon running Solr. Like, I think I did 10 million docs in like 15 seconds. And that doesn't sound all that fast in Spark terms, but a lot of that is just actually reading that amount of data, because these are pretty big docs across the network into Spark. So obviously you only read the fields that you really want. Okay, so let's take it a step further. If you went to Michael's talk earlier, it's really good about Spark SQL. And one of the things he said in there is that Spark SQL isn't just about SQL. It's mainly about, it's mainly like a job optimizer to make sure that the way you're accessing data is as efficient as possible. So in addition to Solr RDD, which as you saw, there's code and all that. But if you actually just want to pull some data out of Solr and then do other types of transformations on it, anything you would do with a data frame. So we have this idea of exposing any Solr query as a data frame. And the cool thing there is, and he actually even talked this about, is that in this example, again, the code's probably not that readable, but the idea is you're not seeing me specify any schema here. So what we do is we actually go out, and Solr has a schema API, and I'm querying the tweets that presumably I indexed in the first part of the talk from Spark Streaming. I'm actually going to go out and query those tweets. And if you just give a query, basically I can build a data frame and infer all the schema information, so you don't have to really worry about that. And behind the scenes, we actually go out, just like he said, sample data from Solr, go into Solr exposes schema API so we can get metadata about fields and all that type of thing. So it makes it very easy to just go ahead and query Solr and then build it into and access it just using selects. I mean, obviously, that's about the depth of my SQL knowledge there, is doing a count with a where filter. But the bottom line is that if you want to access data in Solr through Spark SQL, you can do it very easily. What we don't do yet is actually support the full Spark data source API, which that work's underway, and I should probably have that committed in about a week or 10 days or so. Another little nice thing, and this isn't that exciting, but one of the great things about Spark is you can do this kind of interactive data mining. And so now you can access Solr, and this gives an example. Essentially all you do is register the jar of this project, check it out from GitHub, and then fire up the Spark shell with that jar in the additional jars setting. And so now you can import the Solr RDD and do pretty much everything else we've talked about, and query Solr, expose it as a temp table, and maybe join that with some Hive data. And you can do this all very interactively from the Spark shell. And so that's actually kind of a fun way to get started with this without doing too much work. Is you just obviously have to have a Solr. But you download Solr, index a little bit of data, and then you're off to the races, analyzing it and joining it and mixing and matching it with your data from other systems. So this is another use case that the framework supports, and it's kind of cool because it turns search on its head. So as documents, for example, flow through a streaming job, you can say, well, I want to decide if maybe I should fire off an alert or route documents to a different flow path through my stream or whatever. And one of the cool ways to do that is to actually evaluate Lucene queries or Solr queries against that document. And this is kind of called document matching. The Elasticsearch crowd calls it like percolator and that kind of thing. So built into this is a way for us to basically, as documents flow through, to decide which stored queries those documents match. And the nice thing is that Spark makes that kind of a palatable project because you just basically scale it up to support as many queries and doc throughput as you need by distributing it across Spark. And that's, obviously Spark makes that very easy to do. So I'll give an example of that. So again, our tweets are flowing through the system here, and I essentially do the same mapping step that you mentioned to create the Solr input document. The project gives you the ability to, again, map using basic Java reflection or whatever. But then what I want to do is I want to take this document and decide which of my built-in stored queries does this document match. And again, think of the basic use case there is I want to fire off some alerts to people. If a document with certain features comes in, I want to fire off an alert. And so what we do is we actually go out to Zookeeper and pull the configs and pull that into Spark and pull that into a Spark task. And the reason we do that is because to index a document and match against a query, what do you have to do? You have to actually do all the text analysis to index that document, right? So, you can have very simple text analysis, stemming, lower casing, or you can have very complex. The bottom line is all that text analysis spec is in Zookeeper. So we pull that in and create an embedded Solr server, and then we index documents into that. And that all happens in memory, so it's actually pretty efficient. The next thing we do is then we pull out these stored queries from some data source. Typically it's a database, it could be Solr, it could be wherever. And we essentially run all those queries against the index docs. And then we keep track of which ones match which queries. That scales pretty well, especially if you have a pretty decent sized Spark cluster. Probably tens of thousands of queries. You can still keep pretty good throughput. I've heard of use cases needing like millions of queries, and the problem with that is that you actually need to do some pre-analysis on the queries, and there's a project called LUAC that does that. This doesn't scale to that millions of queries level. I mean, if you had a big enough Spark cluster, you could probably get there, but this is more for tens of thousands of queries you want to match against your documents very quickly. And so it's worth looking at if you're actually interested in document matching type problems. The last thing I want to mention, and then I'll have a few minutes for questions, is the whole MLlib. Most of the time you're actually needing to produce what are called vectors, right? And the vectors are just essentially these term vectors. They have a weight for each feature. And the nice thing is that in Solr, to actually build an inverted index, that metadata is already in there, right? Like TF-IDF is how search is based on. So Solr has the ability for you to actually say when I'm indexing, I want to keep the term vectors for field X, Y, and Z, right? So the project actually allows you to say, okay, well, let me get the term vectors for this query, for all the documents that match this query. I'll pull those into Spark. And you can see I cache that here because that's actually kind of an expensive thing to do. And then now I can pass that on to like a k-means clustering job or whatever. And so this makes it very easy to do that. The downside of this approach is that storing term vector information on the Lucene side is, it kind of really inflates the size of your index. But if you're actually using that information to do machine learning off your data in Solr, then this kind of makes it worth it. It makes it very easy to pull out vectors and use them in Spark, in a very seamless way. Okay, so to wrap up, basically the project is actively being developed. I'm kind of the main person, but I always welcome other people to contribute. And then in terms of where we're going from here, as I mentioned, I'm implementing the data frame, the kind of to be a formal data source, and then also I'm always on the look for kind of new use cases. So if you have an idea and the project doesn't quite fit what you're looking for, then just let me know, and we'd love to work with you on it. So.
Awesome. So before we wrap up, a couple questions here, starting in the front.
Have you tried this with documents of large size, say average is 1 MB, indexing large documents into Solr using Spark? Have you tried that? Can you talk about how it would scale up?
So, yeah, I mean, the nice thing is that you use Spark to scale that problem up, right? And I mean, at the end of the day, it's going to take what it takes based on the size of your document. I mean, Solr can only do so much when you send it a large document. It has to churn through that text analysis. So if you're doing, what I would say there is do a lot of your enrichment as much as possible on the Spark side, because you can scale that wider, right, than you can the Solr. The Solr is sort of a fixed size, right? You have 10 shards or whatever. And it's not as variable as Spark, where you say, Spark, this is slowing down, so I want more tasks, more computation, is how I would deal with larger documents. Most of my tests are around like documents with 20 fields and about 1K on disk. So they're typically smaller docs like tweets and that kind of thing.
Thanks. Yeah, these are all the cool features. Could you also talk about some of the visualizations that could be built on top of Solr? Like graphs, charts.
What's that?
Graphs, charting tools, things like that.
Can you repeat the question?
So could you also talk about some of the visualizations, building charts and then graphs and then on top
okay,
of Solr?
yeah. So this project doesn't really do much with visualizations or anything like that. I mean, it's lower level kind of library stuff for getting access to the data in Solr. If you wanted to visualize it and things like that, I think you can, pass it off to other Spark tools. That's how I approach that one. But hit me afterwards if that didn't cover it. Yep.
Okay. Thank you. I have two questions. The elastic search is very popular lately. So what's the difference between the elastic search and the Solr? And another question, do you think integrating the Spark and elastic search is a good idea?
I don't know if I have enough time to answer the Elasticsearch one. Honestly, they're both really good projects. I think you just have to evaluate it for yourself. Both are awesome and powerful technologies. Where the rubber meets the road on that is, it just kind of comes down to your team skill set, preferences, and requirements. You have to look at it. And then as far as the integrating, I mean, what I see a lot is people have big data, they're employing Spark, and they want to search that big data. And so this project provides that kind of necessary glue of getting started very easily. You set up Solr, you can deploy it on Yarn. You set up Spark, you can deploy that on Yarn, and you can immediately start indexing your big data into Solr to solve your search problem.
Okay, last two questions here.
Yep.
So you mentioned paging through the results. Does that tie in with the lazy evaluation of Spark's graphs?
I didn't get the last part.
So Spark has this lazy evaluation model on the graphs where if I say, I want to look at the top 10 or however many results, it's not going to do the entire data set. It's only going to compute part of that. And
right.
So does the paging fit in with that?
It does. So you have the ability, like when you specify the Solr query, to limit the results. As I mentioned, we're going to be implementing the data source API, which gives a lot more granularity on pushing filters down into Solr a little bit better. One thing I didn't mention is also we stream results back from Solr, so we don't build up a big result set and then ship it across the wire. We're actually start shipping docs that match as soon as we can. But at the end of the day, you know, typically what I've seen is that you essentially use your own filter criteria, and whatever that matches, we ship them all back. So it is obviously, because of how Spark's design, evaluated lazily. So you know, we're not wasting cycles reading data out of Solr, but typically what I've seen is that it will actually, once it generates the Solr query, it'll just page through all those results. But you can control how many you want. And obviously, since it's a search engine, it's bringing back results ranked, right? So if you say I only want 1,000, it's the top 1,000.
Yeah, this is okay. Your answer for last question, please answer part of my question. So you said you don't build a large result size when you trying to draw on data in Spark with data in Solr, and you're moving the cursor, trying to streaming back the data as soon as you get it, right? And my question is, do you do some kind of optimizations that when you're loading the data back, you don't run the query multiple times? Then how about if I run a query with like ordering or sorting based on some field? So how do you handle those orders for the result set?
So the secret there is, you know, part of a Solr query is you can specify the sort order yourself, right? So you know what to sort by. There are a couple problems there. One is if you need a global sort ordering coming out of Solr, it can't take advantage of the shard-based parallelization because it needs to pull those together on the Solr side. So it's not the best use case for that. But the way I look at that is one of the things that Spark does very well is sort. So it's, to me, in my mind, better to actually pull the data out of Solr, and then if you have to do some complex sorting, actually use Spark for that. And so, you know, again, that's where I think this data frame technology and all that comes into play. But, you know, you can control the sort order coming out of Solr just with the query itself.
All right, thanks very much, Tim.